so this is the next question. Students, try this question out and select the correct choice. When we come back, we see how to work this question out. Okay, I hope you all have got the correct solution. So let us see how to do this. So foremost, let me take I to be equal to negative pi to pi cos squared x over 1 positive a raised to the power of x times dx. Let me take x to be equal to negative x, dx is negative dx. So when x is equal to negative pi, our x will become positive. So we can set the limits while we are on the go. So this is going to be pi to negative pi, and this is even function. So it's going to be cos squared x only. My dx will become negative dx and my x is negative x. So this is what we have got. Now I can revert the integrals. So this is going to be negative pi to pi and cos squared x over a raised to the power of x is rewritten as 1 over a raised to the power of x times dx. So this is negative pi to pi, and I can take the LCM, and I have a raised to the power of x and cos squared x dx. I flip this, I get negative pi to pi a raised to the power of x over a raised to the power of x positive 1 times cos squared x times the dx. So this is nothing but I. Now in 1 I have got this, in 2 I have got this. So adding 1 and 2 we get, so 2 times I is equal to integral, my 1 is this, so negative pi to pi cos squared x over 1 positive a raised to the power of x dx. My 2 is this, negative pi to pi a raised to the power of x divided by a raised to the power of x positive 1 times cos squared x dx. I add these two things, I get negative pi to pi. This is going to be 1 positive a raised to the power of x times cos squared x divided by 1 positive a raised to the power of x times dx. Now a raised to the power of x positive 1, a raised to the power of x positive 1 goes up, giving me negative pi to pi cos squared x times the dx. Now cos is even function, right? So cos squared is also going to be even. So I'm going to rewrite this as 2 times integral 0 to pi cos squared x dx. But there is a formula. Cos squared x is nothing but 1 positive cos 2x over 2. So it's going to be 2 times integral 0 to pi of 1 positive cos 2x divided by 2 times the dx. I can rewrite this as 1 over 2 integral 0 to pi dx positive. Now actually this 1 over 2 can go out, right? So this is going to be 0 to pi of cos 2x dx. Okay, fair enough. So this is going to be 2 times of 1 over 2. I integrate this, what do I get? I get x, the limits are 0 to pi. But this one will be off because it will produce a sign. So this is what is left out from the original integral. So 2 multiplied with 1 over 2, I substitute the upper limit minus the lower limit. 2 gets cancelled. I get the answer as pi. So this is what we have got. But on the left hand side you have 2 times I, right? So this means 2 times I is equal to pi, therefore I is equal to pi over 2. Now this is the final solution, and you have to go back and zero in the choice. So why do I get the 2i on the left is because of this value. 2i is on the left. So what is the correct choice? Is it 2 pi? No. Is it pi over 2? Yes. So pi over 2 is the correct choice for the solution, because that's exactly what we have got. So thank you everybody. Please like, share and subscribe.